The second lesson in chapter 6 is volume, slicing, discs, and washes. These are different methods we will use. The learning objectives of this lesson are compute volume by means of definite integration using areas of cross section, find the volume of solid of revolution using the method of discs, and find the volume of solid of revolution by using the method of washes. We will go through all these different methods. So over here, you must remember the disk and washer. A disk is something like this. A washer is having a hole. So the formula changes. And we will come across this one by one. Please watch the videos in continuity. After the first video, go to the next. Don't jump the videos because you need the information and the knowledge of the previous video to understand the next one. So please watch all the videos in this lesson and you will be thorough with all the three objectives. The keywords in this lesson are volume, slicing, washes, discs. You will come across these. Now before we begin with the example problems, let's quickly go through the basic introduction. I've not done any derivations and in detail, but just the basic things to understand this lesson. Volume of by slicing. What does this mean? So now, first of all, it depends on the shape. Whenever you solve the problem, it depends on the shape. But over here, area in this particular cube differs length and width. Over here, it's a cylinder, it differs, it's pi r square. But the volume basically is all the three dimensions multiplied, length, width, and height. Over here, you have pi r square into height. But how can you relate these both? See, you can see something is common. The volume will always be area times height. We already know this. But what you need to understand over here is height is required. It's a constant. It's always there. Area is there, but area differs. See, in this case, it's length into width. Over here, it's pi r square. Now, if you find the area of different objects, then that is enough. Whenever you see a given object, see what is the area, function of area. Then use the formula, you can get it. Now, over here, the area we are talking about is cross-sectional area. Now imagine you won't be finding all this area, this not the surface area, this one cross-sectional area like this. See now this, it's like minutely small one circle over there, right? See now this top surface, only this top surface. This is that cross section only at this. Now the best way to understand this would be if you cut this, okay, small, very small, thin slice, that area we need, the cross sectional area. Okay, over here we can find this pi r square, and then when you multiply this total height, you will get the total volume. Okay, so now one other way to understand is volume is basically how much water that can be filled inside. Okay, so this is the area, cross-sectional area, and total height will be the total volume. So that's the thing. Same way over here, you can relate that over here as well. Now let us see this, the formula which we use, volume by slicing. Over here there is lots of derivation, but if you remember this formula, it is more than enough. Over here, you're cutting into different intervals, small intervals, and then when you integrate it, you will get it. So now you basically reduce this into small intervals, that is dx. This is basically the height or thickness. Okay, a of x is area. See, in the previous one we got it right, area into height. So the same thing over here, volume will be integral from a to b, from the given limit for the given interval a of x dx. So if you use this formula, we can solve the coming problems. In the next video, we will start solving problems and you will understand how to apply this depending on the different questions.